There are several fundamental theorems in mathematics. There's a fundamental theorem of arithmetic, a fundamental theorem of calculus, and several others. We're going to look at the fundamental theorem of algebra, and anytime you get to look at a fundamental theorem, it's kind of a big deal. Now, this one in particular was provided to us by a man named Carl Friedrich Gauss, and he did this in 1799. And the reason that's worth mentioning is because Gauss is widely considered to be one of the top 3 mathematicians of all time. So anytime you get to do anything that Gauss looked at, it's kind of exciting. And what's interesting about this at 1799 was that he was only 22 when he did this, and did this to get his PhD, his doctoral dissertation. So it's kind of a cool deal. Okay, so what the fundamental theorem of algebra says is that if you have a polynomial of degree n being greater than or equal to 1, then p has at least one zero. So what that means is that any polynomial equation at least has one answer. Maybe what's more important as a result of this is what we call the linear factors theorem that says this. If you have a polynomial of its degree n, so we have p of x equals a sub n, x to the n, plus etc., plus a sub 0, then what that means is that we can factor this polynomial just to be a product of linear factors. And this is a direct result of the fundamental theorem of algebra. Okay, so what this means then is that an nth degree polynomial has n factors. Now, some of these linear factors may be complex, some of them may be real, and some of them may be real, but they show up more than once. Okay, so what that means in the graph then is that we have at most n x-intercepts. So if I have a 4th degree polynomial, I know that the 4th degree polynomial's graph cannot cross the x-axis 5 times, right? It can only cross 4 or fewer times. Okay, the last thing this means is that we have something called turning points. We have at most n minus 1 turning points. And what we mean by a turning point is a place where we shift from going up and down. So these are the places where we have a change from going from increasing to decreasing, or from decreasing to increasing, either way. So if you think about a graph, that might mean like a peak and a valley. Okay, and this all comes from the fundamental theorem of algebra, and it tells us a lot about polynomials. So for example, if I had a graph like this, I can figure out kind of what kind of polynomial I'm dealing with. I can see here that at this point, this point, this point, and this point, I change from going up to down or vice versa. All right, so I have 4 turning points. All right, now also notice that I have 3 x-intercepts or zeros. And because of the behavior, since on the one side I'm going down, on the other side I'm going up, I know then my degree has got to be odd. So here I have 4 turning points, 3 zeros, and n is odd. Okay, so from this information, can we say anything about the degree of the polynomial? Well, okay, I know n is odd, and because of the 3 zeros, I know that n has to be at least 3. But remember also because of the turning points, that means n minus 1 has to be at least 4, right? Because you're going to have at most n minus 1 turning points. So that means, and since n is odd, that means that actually n is not only greater than or equal to 3, it's actually greater than or equal to 5. And we know that just from the fundamental theorem of algebra, looking at the turning points, the zeros, and the behavior. Okay, this is an important theoretical concept, and it makes the mystery behind polynomials, well, less mysterious. If you have any questions on this, I'd be glad to help, and thank you for watching.